Today we're going to talk about a problem called find eventual safe states. Okay, we have a graph. Okay, we have a graph and 0, 1, 2, 3, 4, 5, 6. These are nodes, and these are actually the edge. I mean the connections to the node, which is actually an adjacency list in a way. Okay, which says 0. From 0 there like we have a connection to 1 and 2. From 0 we have a connection to 1 and we have an edge to 2. From 1 we have edge to 2 and we have edge to 3. That's what this graph is saying. Okay, so what they're saying is a node is a terminal node if there are no outgoing edges. Okay, if this is a terminal node because there is no outgoing edges from this node. This is also a terminal node, there is no outgoing edges from 5. So all terminal nodes is actually a safe node because the reason is this will never lead to a loop. Okay, this will never lead to a loop. Like take an example. We have a node. Okay, we have a node X. Okay, there are multiple connections outward edge from here. All these edges should not lead to loop. If it is not going to lead to loop, and this edge we can call it as a safe node. Okay, if a node has a lot of edges and if all these edges is not leading it to a loop, then we can call this node as a safe node. Okay, if the node does not have any outgoing edge, then that also we can call it as a safe node. That's the whole problem is that's what, like if you understand this, then the entire problem is solved. Okay, let's talk about how do we do that. Okay, take this example. We have a 0. We start from here. Okay, we start from here and we go to 1. Okay, because we have multiple edges, we have only one outward edge from 0 to 1. From 1 there are 2 edges, 2 to 3. First we'll explore 2. Okay, we go to 2, and from 2 there is only one outward edge which goes to 5, and from 5 there is no outward edge. If there is no outward edge, then we can call it as a safe node. Okay, let's have a safe node, and 5 is actually a safe node. So since there is no outward edge from here, we backtrack, come to 2, right? We backtrack and come to 2, and from 2 there is only one outward edge which we explored. There is no other edges. All edges doesn't lead to loop, then we call 2 is also a safe node. From 2 we backtrack to 1. 1 has 2 edges, like one which goes to 2 and which goes to 3. Whatever goes to 2 we already explored and we are good. If you take this path, it doesn't lead to any loop, but we'll also have to explore whether this leads to loop or not. We go to 3. From 3 there is only one edge which leads to 0. In the current path we started with 0. This actually creates a loop. Okay, then what we have to do is like this is not going to be a safe node. 3 is not a safe node. Okay, if 3 is not a safe node, wherever the entire path will become not safe, because 0 leads to 1, 1 leads to 3, 3 leads to 0, then this whole 0 is not safe, 1 is not safe, and 3 is already not safe. Okay, then is entire stuff 0, 5 is explored, 2 is explored, 3 is explored, 0 is explored, 1 is explored. The unexplored nodes are 4 and 6. We go to 4 and we try to explore. There is only one outward edge which goes to 5. Okay, and then 5 is a terminal node which is already safe. We have recorded it and we have a 4. There is no other outward edge other than going to 5. Then 4 can also become a safe node. Then we call it as safe. And the unexplored node is 6. 6 is from 6 we can go to, there is no inward edge, there is no outward edge, then it is safe node again. Okay, if you find out the safe nodes 4, 6 and 2, 2 and 5. Okay, 2, 2, 2, 2, 2, 4, 5 and 6, these are the safe nodes. If you see 2, 4, 6, these are the safe node. This we can do it using DFS.